Welcome everyone to our channel Mathematics Parshala. This is another problem of CSIR UGC NET Mathematical Science, and the question ID is 704066. See the question here. Let us now try to solve this problem slowly. There are three statements A, B and C, and it says that which of the following options are true. So let us first study the statements one by one. So first look at the option A. Let f be a continuous function on 1 infinity and it takes only non-negative values. So clearly this function is like that. This function is like that, f such that 1 infinity to 0 infinity, because it takes only non-negative values. Now says that this is given that integration 1 to infinity fx dx converges. It is given that this is convergent, and the question is then summation fn n equal to 1 to up infinity or n greater than equal to 1, this should converge. So if f is a continuous function and from here to here, and if this integration, this improper integral convergent, then the question is if this summation converges or not. So look at the function. Let us now try to define that in a function in such a way. Just look the figure of the function. Say here 1, say here 2, here 3, 4 and so on, and let us now try to define the function in such a way that say this is our 1. Just only see the figure of the function. If we can construct a function like this, say this point delta 1, this is say 1 plus delta 1. So this distance is delta 1, this distance is delta 1. From here to say take here some say 2 minus delta 2, and this point 2 plus delta 2. So the function is defined in such a way that from delta 1 to delta 2 this is 0, and then again from this 2 minus delta 2 the function is like this, and in 2 it is this maximum point, local maximum point, and then again it decreases to 2 plus delta 2, and take here also say 3 minus delta 3, and here say 3 plus delta 3, and from 2 plus delta 2 to 3 minus delta 3 is again fx equal to 0, and then again from here it increases at the point 3, it reaches maximum, local maxima, and then again it decreases to 3 plus delta 3, and so on. In this way the function may be constructed. See, we are taking this point, this is half, and taking this point, this is 1 by 3, and so on. In this way we can construct a function like this. So this is very clear that this function is clearly a continuous function and also taking non-negative values on r. And also this is very clear, there's this delta 1, delta 2, this delta 1, this delta 2, delta 3, we can choose as our wish. Now just let us calculate this integration 1 to infinity fx dx. If we calculate this integration 1 to infinity fx dx, then clearly this will be our area, and the area is divided in some parts. This is clear here. This is our first part, this is our first part, and clearly the area of this portion is equal to our, this is a triangle, right angle triangle, so half into its base, this distance is delta 1, and into height, and height is our 1 by our construction. Then plus in this position delta 1 plus 1, from delta 1 plus 1 to 2 minus delta 2, the value is 0, so this doesn't give any value. So then from 2 minus delta 2 to 2 plus delta 2, we will give a value for the area. So this will be, again, see, this is the right angle triangle into two portion of two right angle triangle. So, and this is symmetric, left, the area of left side equal to the area of right side, so this is equal to also 2 into our one of the area of triangle, so half into base is our delta 2 into height is our half. And also then similarly for this portion, the third portion, and this is our area is 2 into one area of one triangle, so half into our base, that is delta 3, into height is our, by construction, 1 by 3, and plus dot dot so on. So just simplify this, we will get half delta 1 plus this 2, after cancelling out we get half delta 2, plus after cancelling these 2 and 2 we get half delta 1 by 3 delta 3, and then for the next part we will get 1 by 4 delta 4 plus dot dot so on. And this is very clear that this delta 1 we can choose whatever we wish. So we are choosing this delta 1 as no problem, just leave it delta 1 whatever, and choose delta 2 less than half, and choose this delta 3 less than 1 by 3, and then we will choose delta 4 less than 1 by 4, and so on. Then our this value will be less than this is half delta 1 plus this delta 2 less than half, so this will be half square, then this 1 by 3 into delta 3 less than 1 by 3, so this will be 1 by 3 into 1 by 3, 1 by 3 square, then this will be 1 by 4 square, and so on. And clearly this is actually our like p series, from this portion to this portion there is actually 1 by n to the power p for p equal to 2. This is actually half delta 1 plus summation n equal to 2 to infinity 1 by n square. This is p series for p greater than 1. So this is clearly convergent, and this is also a constant term, so the sum of this will be a convergent. So clearly our integration 1 to infinity fx dx is convergent. But just now calculate Now here summation n greater than equal to 1 fn, this will be our, by our definition, see our f1, this is actually f1 plus f2 plus dot dot. See our f1 is by definition 1, f2 is 1 by 2, f3 is 1 by 3, and so on. So this is actually p series 1 by n to the power p for p equal to 1, and clearly this is a divergent series. So option A is not a correct option. Because we get integration 1 to infinity fx dx convergent but summation fn divergent. So option 1 is not correct option. Option A is false. Now look at option B. See here, f is a function, f may not be continuous, just says that f is a function from 1 infinity to 0 infinity because it takes non-negative values, and also given that 1 to infinity fx dx convergent, then says that limit x tends to infinity fx equal to 0. Now see, again we are defining a function like that. We are defining a function f for option B, f from 1 infinity to 0 infinity, just defined in this way that fx equal to, we will take 1 if x belongs to natural number and 0 otherwise if x does not belong to natural number. So the figure of this fx will be like this. It's 1 2 3. So at 1 it will be, say here 1, at 2 it will be 2, at 3 it will be 1, and in this portion it will be 0. So clearly the function is not continuous, and if we calculate this integration 1 to infinity fx dx, so this is very clear that this is, we can write as limit n tends to infinity integration 1 to n fx dx, and clearly this integration will be 0 because only finite, only discrete, there are countably many points where f takes non-negative values, otherwise f will be 0. So clearly this value will be 0. But here see, limit x tends to infinity fx actually does not exist. X tends to infinity fx does not exist because if we take a sequence xn equal to n, then limit x tends to infinity, then here xn tends to infinity, here xn tends to infinity, and clearly all fxn will be 1 because at natural numbers f will take 1. So is a constant sequence fxn equal to 1 for all n. So limit n tends to infinity fxn will be 1. And also if we take yn, another sequence, that will be not natural number. Take any epsilon, that is 0, or take just yn equal to say n minus half. So clearly all f of yn equal to 0 by our definition. So yn tends to infinity, but our f of yn tends to 0 because all f of yn equal to 0. So there are two different sequences such that xn tends to infinity, fxn tends to 1, and yn tends to infinity, fyn tends to 0. So limit x tends to infinity fx does not exist. This is does not exist. Now look at option B. Option B, we have given an example of a function f such that integration 1 to infinity fx dx convergent, but limit x tends to infinity fx does not exist, that is not equal to 0. So clearly option A and option B are not true. Now look at option C. It is given that f is a function continuous decreasing and same taking non-negative value from 1 infinity to 0 infinity, and also given that integration 1 to infinity fx dx does not converge, then says that summation fn does not converge. So let us now study this statement. First see the structure of this type of function. Say this is 1, say this is 2, this is 3, and so on. Say the function may be constant. Function may be constant. So if this is constant function, say fx equal to k, then clearly integration 1 to infinity fx dx does not converge. Clearly 1 to infinity fx dx does not converge, and also here summation fn n equal to 1 to up to infinity, n equal to 1 to up to infinity does not converge. This will be our summation. If we take k out this summation, then it will be n equal to 1 to up to infinity 1. So this definitely is a divergent series, does not converge. And if this k is like that, this is not a constant function, so it will be continuous and decreasing. Suppose if we start from here at 1, f1 maybe whatever, say k or lambda whatever. So from here the function is continuous and decreasing, so it should be like this. It should be like this. This is very clear from the definition of function. And now see this figure. See this integration 1 to infinity fx dx can be written as integration 1 to 2 fx dx plus integration 2 to 3 fx dx plus dot dot and so on. And see here this is our area. Integration 1 to 2 fx dx is this area, and if we just take this rectangle, then we will get this area of this rectangle as f of 1 into this length 1. And clearly this integration 1 to infinity fx dx less than equal to our f1 into 1 by the figure, because f is decreasing, maybe constant or maybe there are some portion here. And similarly, if we draw this rectangle from f2 to here, so integration 2 to fx dx is our this region, integration 2 to 3 fx dx is our this region, and the area of this rectangle will be our f of 2 into this length 1. And if f is constant, then it will be, there will be no portion here, this will be equal. And if f is not constant, there will be portion here. So this is less than equal to this. And similarly, integration 3 to 4 fx dx will be less than equal to our f3 into 1 and so on dot dot. So this is actually our f1 plus f2 plus f3. So this is actually our summation fn, n greater than equal to 1. So see, we get a relation that integration 1 to infinity fx dx less than equal to summation n fn. So clearly, if this portion convergent, summation n fn convergent, then integration 1 to infinity fx dx will be convergent by comparison test. And from other side, if integration 1 to infinity fx dx does not converge, then summation n greater than equal to 1 fn does not converge also by comparison test. Now look at option C. Look at our option C. It says that if 1 to infinity, integration 1 to infinity fx dx does not converge, then summation fn does not converge. What actually we get? So from our observation, what we get, option A and B are false and option C is true. So see the options. One says that A, B, C are all true, but we get A, B are not true. So 1 will be not correct option. Look at option 2, both A, B are false, which we get A, B are false. Option 3 says that C is true, we get C is true. Option 4 says that B is true, but we get B is false. So correct option is 2 and 3, and 1, 4 are not correct option. Thanks for watching. We will meet in the next video.